हेलो दोस्तों, कैसे हैं आप? सो दोस्तों, टुडे वी आर गोइंग टू स्टार्ट विद वन मोर important topic of class 12th, application of derivative, and in this we will be discussing about the tangents and normal. So we have already solved around 10 questions of tangents and normal. We will try to solve all the remaining questions from the exercise. Okay, and welcome to GRV classes. Thank you very much for your time. So let's start. My name is Gaurav Tyagi. चलो करते हैं स्टार्ट फिर से. अब देखो इसमें वट एवर इज गिवन टू अस एंड व्हाट वी हैव टू फाइंड आउट. लेट्स सी एंड ट्राई टू सोल्व. So in this what we need to do is to find the equation of all the lines having slope 2. So there may be a one more, there must be a more than one line. Okay, so we are talking about lines here, so there must be more than one. Okay, there should be a more than one type of line and which are tangent to the curve. Okay, but the slope of the tangent line is given to us, and as we know the slope dy by dx is equal to slope of the tangent line. So let's try to figure it out how we can solve this. So here we have slope of the tangent line is given to us 2. ठीक है, slope of the tangent line is given to us 2, and as we know that slope of the tangent line is dy by dx, or you can say f dash x. Okay, so dy by dx is equal to d by dx of 1 upon x minus 3. Okay, and if you solve this equation, so it will be 1 minus 1 x minus 3 whole square. Okay, and this is this must be equal to 2. Okay, so minus 1 upon x minus 3 square is equal to 2, and this is the first equation that we have, and this is the second equation that we get from solving by finding dy by dx of the y. Okay, and if we try to equate these two equations, if we try to equate like these two equations, so what do we get here is, let's see, if we try to equate these two equations, 1 minus x minus 3 whole square is equal to 2. So if we equate these two equations, so equating, we can write down equating equation 1 and 2. Okay, so that will be x minus 3 square into 2 is equal to minus 1. Okay, which is x minus 3 square is equal to minus 1 by 2. So guys, as you can see here, x minus 3 square is equal to minus 1 by 2. So that is not possible, because we cannot have a positive value when we do square of a negative number. Sorry, we cannot have any value when we do, so under root of negative number does not result in any real values. It will give us only complex value, and here we will not have any lines, any tangent line with slope 2, because x minus 3, as you can see here, x minus 3 will be equal to under root of minus 1 by 2. So under root of minus 1 by 2 will not result into any of the positive or real values, you can say. So any of the real values will not be possible from here. So we'll simply write down, hence there is no line, there is no tangent with slope 2, there is no tangent with slope 2 to this curve. ठीक है, so there is no tangent with slope 2 to this curve. Okay, so we'll simply write it down, and so this is the one of the way to figure out कि हम कैसे निकाल सकते हैं like equation of line. So equation of line, equation of a tangent of a line are not possible in this case with slope 2. Okay, and I hope you have understood. So let's try to check it out, and before we move on, I'll check the sound system. Just give me a minute, guys. Okay, let's see. Before I'll check, you can simply try to solve this question.
Okay, let's see.
Okay, the sound is good. Okay, the sound is coming good. Okay, now we can try to solve one more question from the same topic. Now we can try to solve one more question from the same topic, and in this question as well, we need to apply the same logic, we need to apply the same formula. Okay, so what we have to do here is what we have to do here is, so we'll simply write down that slope of the tangent line. Okay, slope of the tangent line is equal to 0. Okay, and that will be equal to dy by dx, or you can say f dash x. Okay, so y is given to us here. So y is given to us, y is equal to 1 upon x square minus 2x plus 3. Okay, and what do we find? So we'll try to find out dy by dx from here. So dy by dx, as we know, is dy by dx of the y. Okay, and we'll simply write it down, x square minus 2x plus 3. Okay, so how do we solve this? So this can also be written as minus x square minus 2x plus 3 square, and in the numerator, what do we have here is 2x minus 2. Okay, and how did I solve it? So we can use the either we can use quotient rule, or we can simply write it down, x square minus 2x plus 3 to the power minus 1, then minus 1 comes before it, and then square of the term, and then by using chain rule, dy by dx of 2x x square minus 2x plus 3. So like this we can solve. Okay, so if you need to, guys, if you need to learn how to find out dy by dx of the function, so you have to check out the differentiability. Okay, check out the video of the continuity and differentiation. I have discussed this in detail. Okay, and let's move on. And if you have any difficulty in solving this at this point of time, so please do write down in the comment box. I'll give you the separate link of it. Okay, so dy by dx of 1 by x square minus 2x plus 3. Okay, and how do we solve it further? So let's see. So dy by dx is equal to, this is now 2 minus 2x upon x square minus 2x plus 3 whole square, and that should all be equal to 0. Okay, and if we create that equal to 0, so what do we get from here is, let's see, what do we get from here is 2 minus 2x equal to 0, or 2 is equal to 2x, or from here we get simply x is equal to 1. So x is equal to 1 is the point, x is equal to 1 is the only point where the slope of the tangent line is equal to 0. Okay, so we'll try to find it. So we'll try to find the y coordinate of this point. Okay, so y coordinate of this point will be figure out, can be solved by using this. So y is equal to, so we'll simply put x is equal to 1 into the equation, x square 1 square minus 2 into 1 plus 3. Okay, and that is equal to 1 upon 1 plus 3 is 4, 4 minus 2 is 2, so that is 1 by 2. Okay, so for x is equal to 1, we get a point, y coordinate of the point where the tangent to the curve having slope 0. Okay, so this is the point. We'll simply write, this is the required point where slope of the tangent is 0, where the slope of the tangent is 0. Okay, and we'll use that, and we'll simply write down the equation, y minus y naught is equal to mx minus x naught. So guys, as you can see here the m is 0. Okay, the slope is given to us, which is 0. Okay, and x minus x naught will not have any multiplied by 0 will be 0 only. So y minus 1 by 2 is equal to 0, or you can simply write down y is equal to 1 by 2. So that is the equation of the line, that is the equation of the tangent line having slope 0. ठीक है. So this is the equation of the tangent line to the curve having slope 0. Okay, so this is how we can solve, and I hope you have understood and get the logic of the question. Okay, so if you have any difficulty in solving this type of question, so please let me know, and let's move on and try to solve one more question from the same topic. Okay, so guys, let's move on. So let's see how it goes. So here we have find the point on the curve. Okay, so we need to find on the curve, this equation is of ellipse, as we know. The point on the curve at which the tangents are parallel to x-axis. So guys, as we have discussed, when the tangents are parallel to x-axis, so the slope of the tangent line is 0. Okay, dy by dx is equal to 0, and when it is parallel to y-axis, the slope is 90 degree. It means dx upon dy is equal to 0. So guys, dy by dx will be infinity, so we'll simply reciprocate it, so dx upon dy will be 0. Okay, so let's see and solve how the equation goes. So in this question, what we have to do, let's try to solve from the first part. X square by 9 plus y square upon 16 is equal to 1. We'll simply write down, since tangents are parallel to x-axis, hence dy by dx is equal to 0. Okay, so we'll simply equate it to 0. We'll find out the dy by dx first. So dy by dx is equal to dy by dx of this whole equation, x square by 9 plus y square by 16, or you can say this y term. Okay, but here we have x square plus 9, so we can differentiate it implicitly. Okay, so we can differentiate it implicitly because this is not explicit kind of equation. Explicit differentiation is possible when the equation is given in the form of y is equal to fx. Explicit differentiation when equation is given in the form of y is equal to fx. Implicit when it is not given in this form, or x square y square are combined together. So for one of the way to change it, like we can change it into explicit, y taken to one side and rest to other, but we'll simply using the implicit differentiation. We'll simply write using implicit differentiation. Okay. Implicit differentiation means we'll solve it, like we'll not change its form and we'll simply solve it. Okay, so it will be dy by dx of x square by 9 plus y square by 16 is equal to dy by dx of one. Okay, and this will be 2x by 9 2y by 16 dy by dx is equal to 0. Okay, and from here, as you can see, 2 will get eliminated, this 2 will get eliminated. Okay, and we'll simply write down dy by dx is equal to minus x by 9, and this will be y by 16. Okay, and dy by dx from here we get is equal to dy by dx is equal to minus x upon y 16 upon 9, and if that is equal to 0, so what do we get here is, so if that is equal to 0, it means x is equal to 0. Okay, so it means x is equal to 0 because if some 0 upon something is, or 0 into something is 0 only, so it means x must be 0, the variable x must be 0. Okay, so we get x is equal to 0, and we'll try to put that point into the given equation. Okay, so we'll simply write down, let put x is equal to 0 into x square by 9 x square by 9 plus y square by 16 is equal to 1, and we get, we'll simply write what do we get from here. So it will be y is equal to y square upon 16 is equal to 1, so y is equal to plus minus 4. Okay, so for x is equal to 0 we get 2 points, for x is equal to 0 we get 2 points, 0 and plus 4, and we will get 0 and minus 4. Okay, so these are the 2 points that we get from here. Okay, and we need to find the points on the curve. So we get 2 points where x is equal to, where dy by dx is equal to 0 parallel to x-axis. Okay, and I hope this is clear to you, and we'll try to solve the second part from here. Okay, and in the second part dy by dx is equal to infinity, ठीक है, और dx upon dy is equal to 0 since tangent is parallel to y-axis. Parallel to y-axis. So let's try to solve this question, and in this what we have here is, we'll simply using the implicit differentiation, using the implicit differentiation here. ठीक है, so we'll implicit differentiation में अभी हम क्या करेंगे, we'll simply write dy by dy, we'll simply write dy by dy of x square by 9 plus y square upon 16 is equal to d by dy of 1. Okay, and what do we get from here is, let's see, so that will be 2x by 9 dx upon dy plus 2y by 16 is equal to 1. So guys, as you can see here, if constant is differentiated with respect to anything will result into 0 only, because constant cannot be changed. Okay, it will remain same and there will not be any change in it. Okay, and here we have to put dx upon dy is equal to, here we have to put dx upon dy is equal to 0. So let's see how it goes, and we'll simply write down dx upon dy. So again 2 will get cancelled out from both the equations, from both the terms. Okay, and that will be minus y upon 16 into 9 by x, or you can simply write down minus y upon x 9 by 16, and from there here we get y is equal to 0, because as we have discussed earlier, anything upon 0 upon anything is 0, or 0 into anything is 0, so y must be 0 here. Okay, so y must be 0, so we get one of the point, and using that point for x is equal to 0, sorry, for y is equal to 0, for y is equal to 0, x square plus 9 y square plus 16 is, or we'll simply write substituting, we'll simply write substituting y is equal to 0 into this equation. ठीक है, into this equation will result into, we get so y is equal to 0 will result into x square upon 9 is equal to 1, and from here we get x is equal to plus minus 3. Okay, so we can simply write it down from the calculation that we from the simplification, that for x is equal to 3 y is 0, and for x is equal to minus 3 y is minus 0, sorry, minus 3 y is 0 again. So these are the 2 points when, okay, so these are the 2 points when tangent is parallel to y-axis, and on the above we get 2 points 0 and 4, 0 and minus 4 when the tangent is parallel to x-axis. Okay, and I hope this is clear to you, and you must not be having any confusion in solving this type of question. Okay, so let's move on and try to solve one more question, and I hope guys you have understood this part as well. Okay, so if you do understand and like the video, so please do subscribe to the channel and click the like button and share it with your friends to get the maximum benefit. Okay, so I have been doing it for you, so please you do something for me as well. And here we have question number 14. So find the equation of the tangent and normal to the given curve at the indicated point. Okay, and what we need to find is equation of the tangent and normal to the given curve. So curve is given to us and we'll find dy by dx. Okay, and this the point is given to us and we'll simply write down the equations of the tangent and normal. Okay, and as we know, if the tangent is m1, so normal will be m2, and that should be the product of these two will be -1. Okay, so let's start from the very first question. Here in this question, let's see how it goes. So slope of the tangent to slope of the tangents to the curve. First of all, we'll see slope of the tangent to the curve, which is dy by dx is equal to d by dx of x की power 4 6x cube plus 13x square minus 10x plus 5. ठीक है, so dy by dx will be equal to so that is 4x cube minus 18x square plus 26x minus 10, and that's okay, and we'll simply find out the slope of the tangent at the given point, and the given point is x is equal to 0. ठीक है, so given point is x is equal to 0 at 0 and 5. Slope of the tangent to the curve at 0 and 5. ठीक है, so that should be minus 10 because all the terms having x will be 0. So dy by dx at x is equal to 0 is minus 10. So that is the slope of the tangent to the curve. Okay, and equation of tangent to the curve, we'll simply write down equation of tangents to the curve, that will be y minus y naught is equal to m x minus x naught. ठीक है, and here the point is given to us. ठीक है, so x naught and y naught is given to us, which is nothing but 0 and 5. So we'll simply write down the equation y minus 5 is equal to minus 10 x minus 0, or y is equal to minus 10x plus 5. So this is the required equation of the tangent to the curve. ठीक है, now we'll simplify it, slope of the normal to the curve. We'll simply write down slope of normal to the curve. ठीक है, so that will be, if that is m1, so m2 is equal to minus 1 upon, ठीक है, minus 1 upon m1, and that should be minus 1 upon minus 10, so that should be 1 upon 10 only. Okay, and equation of normal to the curve, equation of normal to the curve is y minus y naught is equal to minus 1 upon m x minus x naught. So we'll simply write it down, y minus 5 is equal to 1 upon 10 x minus 0, and which is nothing but, we'll see that tan y minus 50 is equal to x. Okay, or you can simply write tan y is equal to x plus 50. ठीक है, so these are the two equations that we got from here. This is the equation of normal to the curve in the first case, and this is equation of tangent to the curve, ठीक है. This is equation of tangent to the curve and this is equation of normal to the curve. Okay, and I hope guys you have understood this part as well, and if you have any difficulty in solving this and knowing any part of the solution, so please let me know. And here we have second question. Here we have second question. Or second question mein again guys what we need to do is to find the equation of tangent to the curve and normal to the curve. Okay, and as we have discussed here, so first of all what we do is try to find out the slope of the tangent line. Okay, the slope of the tangent line is nothing but dy by dx. Okay, so we'll simply write down equation here and we'll then try to solve it. So y is equal to x to the power 4 minus 6x cube plus 13x square minus 10x plus 5 at 1 and 3. Okay, so this is given to us. We'll see that. Okay, so what we do here is we'll simply try to solve this equation, and in this equation what we do here is simply we'll find out slope of the tangent to the curve at slope of tangent to the curve is dy by dx. ठीक है, और dy by dx is equal to dy by dx of x to the power 4 minus 6x cube plus 13x square 10x plus 5, and that should be equal to 4x cube minus 18x plus 26x minus 10 at 1 and 3. ठीक है, so the equation is similar and we need to find that at 1 and 3. Okay, so dy by dx at x is equal to 1, at x is equal to 1, this should be equal to 4 minus 18 plus 26 minus 10, and that should be 26 plus 10 is 26 plus 4 is 30, 30 minus 28 is 2. So dy by dx at x is equal to 1, so slope of the tangent to the curve is 2. Okay, and equation of tangent to the curve is, as we know, y minus y naught m x minus x naught. ठीक है, और this is m, this is nothing but at, so the tangent to the curve at, we'll simply write x naught y naught is equal to 1 and 3. Okay, so we'll simply put that into the standard equations, y minus 3 and m is, as we have calculated, is 2 and x is x minus 1. Okay, so y is equal to 2x minus 2 plus 3, and that will result into y is equal to 2x plus 1. ठीक है, so that is equation to the tangent to the curve. ठीक है, now we'll simply write down equation of normal to the curve. Okay, slope of normal to the curve is equal to, if it is m2, then that should be minus 1 upon m1. Okay, and if it is m1, like if this is m1, ठीक है, and that should be minus 1 upon that should be minus 1 upon 2. So minus 1 by 1 minus 1 upon 2 is the normal to the curve, slope of normal to the curve. ठीक है, and equation of normal to the curve will simply write down equation of normal to the curve. How much it will be? This will be y minus y naught minus 1 upon m x minus x naught. So y minus m, y naught is how much? So y naught is 3. Y naught is 3 minus 1 upon 2 x minus 1. Okay, so that will result into y is equal to minus 1 by 2x plus 1 by 2 plus 3. Okay, or we can solve it further. Minus 1 by 2 plus 7 by 2. Okay guys, and I hope you have enjoyed and learned this part. So I'll give me a minute. I'll be back in right Okay, hello guys. Okay, so there was some. Okay, so let's start to solve one more question. Okay, and here we have y is equal to x cube at 1 1. Okay, so the graph is, the curve is given to us, y is equal to x cube at 1 1. So let's see. ठीक है, अब इसमें हम क्या करेंगे, इक्वेशन ऑफ दैट स्लोप ऑफ द टेंजेंट टू द कर्व एज वी नो इज slope of the tangent to the curve is dy by dx. Okay, and dy by dx is nothing but d by dx of y. So here y is given to us x cube. Okay, so that will be 3x square. ठीक है, और यहाँ पर हमें we'll have to find the dy by dx at the given point, and dy by dx x is equal to 1. Okay, so dy by dx will be equal to 3 because 3 into 1 square is 3. ठीक है, so that is m1, or you can simply write m, slope of the tangent to the curve. Okay, so we'll simply write equation of tangent to the curve, as we know, is y minus y naught is equal to mx minus x naught. Okay, and y minus y naught as is given to us, so this is x naught and this is y naught here. Okay, and y minus 1 is equal to 3x minus 1. Okay, and that will be y is equal to 3x minus 3 plus 1. Okay, and that will result into y is equal to 3x minus 2. So that is the equation of the line, equation of tangent to the curve at the point 1 1. Okay, and we'll simply find out the equation of normal to the curve in the similar manner. Equation of normal to the curve is y is minus y naught is equal to minus 1 upon m x minus x naught, and the m with that we have calculated will be used here. Okay, and y minus 1 is equal to minus 1 upon 3 x minus 1. ठीक है, so that will be 3y minus 3 is equal to minus x minus, sorry, minus minus plus, so this will be 3y plus x is equal to, and that will be 4. Okay, so this is how we can solve the equation of the tangent to the curve and equation of normal to the curve. Okay, and we'll try to solve the fourth part in the similar manner. Okay, and guys, if you have any difficulty in solving this type of question and knowing and how to solve this type of question, so please let me know if you have any difficulty in this. So here we have y is equal to x square at 0 0. Okay, so here we have y is equal to x square at 0 0. We'll see how it goes. So y is equal to x square at 0 0. So 0 0 here is x naught or y naught. These are the point. Okay, so we'll simply write slope of the tangent, slope of tangent to the curve, slope of tangent to the curve is dy by dx. ठीक है, or as we know the dy by dx is how much? dy by dx is dy dx of x square which is nothing but 2x. dy by dx is equal to dy by dx of x square, which is 2x. Okay, and dy by dx at 0 0, or you can simply write x is equal to 0. ठीक है, at x is equal to 0 it is 2 into 0 is 0. टू इंटू ज़ीरो इज जीरो. ठीक है, तो ज़ीरो को थोड़ा सा बड़ा बना देते हैं. एंड हेयर वी हैव इक्वेशन ऑफ टेंजेंट टू द कर्व. इक्वेशन ऑफ tangent to the curve is y minus y naught mx minus x naught. ठीक है, तो हम क्या करेंगे इसमें, we'll simply write down y minus 0 is equal to 0, x minus 0, so that is y is equal to 0 only. ठीक है, so at this point the slope of tangent, the equation of tangent to the curve is y is equal to 0, which is the x-axis. Okay, so this is a square function, so the tangent to the curve will be x-axis here. Similarly, we will simply find out equation of normal to the curve. Equation of normal to the curve, y minus y naught minus 1 upon x minus x naught. So y minus 0 is equal to, so dy by dx, that is 1 by 0 x minus 0. ठीक है, so y is equal to infinite, y is equal to infinite, that is the equation of normal to the curve. Okay, so that is equation of tangent to the curve, and this is the equation of normal to the curve. ठीक है, so this is how we can solve. And y is equal to infinite is the line parallel to y is equal to infinite. Okay, so let's see, and let's try to solve one more question of the same type, and there is one more part to the given question. So we have solved 4 part of it, and there is one more part given to us, so that is y is equal to x is equal to cos t, y is equal to sin t, at t is equal to pi by 4. Okay, so we'll see that. This is the 5th part here. X is equal to cos t, y is equal to sin t, at t is equal to pi by 4. Okay, this is the question. X is equal to cos t, y is equal to sin t, at t is equal to pi by 4. Okay, so here we have, so in order to find slope of the tangent to the curve, slope of the tangent to the curve, which is dy by dx, and in order to find dy by dx, what we do here is we'll simply write dy by dx is equal to dy by dt upon dx by dt. ठीक है, dy by dt is how much? It is, if we find out dy by dt from here, ठीक है, so dy by dt अगर हम यहाँ से निकालें, so dy by dt will be equal to dy by dt of sin t, which is cos t. Okay, and similarly if we find dy dx by dt, which is dy by dt of cos t, so that will be minus sin t. ठीक है, so guys, we'll simply find out dy by dx here. dy by dx is minus, sorry, plus cos t minus sin t, or you can simply write cot t. ठीक है, so cot t आ गया हमारा dy by dx. Now what we need to do is we need to find the value of the slope of the tangent to the curve at So dy by dx at t is equal to pi by 4 is equal to minus 1, or that is the slope of the tangent to the curve. ठीक है, and from here we'll simply find out the value of x and y as well. ठीक है, so the coordinate given to us, so at we'll simply write at t is equal to pi by 4, x is equal to cos t is given to us, x is equal to cos t is given to us, so x is equal to cos pi by 4, which is 1 by root 2, and sin y is equal to sin pi by 4, which is again 1 by root 2. ठीक है, so x naught and y naught, the point on the curve where the tangent is drawn is 1 by root 2 and 1 by root 2. Okay, and we'll use that and we'll simply write down the equation of tangent to the curve. Equation of tangent to the curve is nothing but y minus y naught is equal to m x minus x naught. Okay, so y naught is 1 by root 2, m is minus 1, x minus 1 by root 2. Okay, so y is equal to minus x plus 1 by root 2 plus 1 by root 2. Okay, and if you solve 1 by root 2 plus 1 by root 2, so that will be 2 upon root 2, and 2 upon root 2 is nothing but root 2 only. ठीक है, so this can again be simplified to y is equal y plus x is equal to root 2. Okay, so this is how we can simplify this, and this is equation of equation of tangent to the curve. Okay, now we'll simplify an equation of normal to the curve using the same technique. So equation of normal to the curve, equation of normal to the curve here. So equation of normal to the curve is y minus y naught is equal to 1 upon m x minus x naught. Okay, and that will be y minus y naught is how much? 1 by root 2, and slope as we have find out is 1 only, because minus 1 upon m is minus 1, and minus 1 upon m is minus 1 upon m is plus 1. Okay, so x minus x minus 1 by root 2. Okay, so y is equal to x minus 1 by root 2 plus 1 by root 2. Okay, so equation of normal to the curve will be y is equal to x only. Okay, so equation of normal to the curve will be y is equal to x only. Okay, so this is how we can solve this type of equation, and if you have any difficulty in solving this type of question, so please let me know, guys, and I hope you have enjoyed and learned this part. And let's try to solve few more questions on the same topic and discuss how we can solve this type of question. Okay, and here we have find the equation of tangent line to the curve. Okay, and parallel to the line. Okay, so when, as we have discussed, when the two lines are parallel to each other, so when the two lines are parallel to each other, their slopes are equal. Okay, we'll use that property and we'll simply solve it. Okay, so we'll start from A part. We'll simply write slope of the parallel lines are equal. ठीक है, so 2x minus y plus 9 is equal to 0. Comparing this equation, with slope intercept form, y is equal to mx plus c. ठीक है, सो इसमें हमारा है y is equal to 2x plus 9 and here we have y is equal to mx plus c. So clearly m is equal to 2. ठीक है, so m is equal to 2. So now we will find the slope of tangent to the curve. Slope of tangent to the curve y is equal to x square minus 2x plus 7 is 2, क्योंकि parallel lines have equal slope, and dy by dx is equal to dy by dx of x square minus 2x plus 7, and that will be 2x minus 2, and that should be equal to 2. ठीक है, so is equal to dy by d. Two x is equal to 4, so x is equal to 2 here. Okay, and since the point is known to us now, the x is equal to 2, so we will find the y coordinate of the point. ठीक है, so y is equal to, ठीक है, so using substituting the value of, we'll simply write substituting x is equal to 2 into y is equal to x square minus 2x plus 7 to get y coordinate. ठीक है, so that will be y is equal to 2 square minus 2 into 2 plus 7, so that is 4 minus 4 plus 7, which is 7 only. Okay, so we get a point, x is equal to 2 and y is equal to 7. Okay, and the slope of the tangent line is also known to us now, and what we need to find is equation of tangent to the tangent line. Okay, so equation of the tangent line is y minus y naught m x minus x naught. ठीक है, and here we have x naught and y naught is equal to 2 and 7, and m is equal to 2. m भी हमारा 2 ही आया था, देखें, yes, m is equal to 2. So substituting into the given equation, we'll simply write substituting into the, or you can simply write plug in the value, ठीक है, plug in the value. So y minus 2 is equal to 2x minus 7. We'll solve it further. So y is equal to 2x minus 14 plus 2. So y is equal to 2x minus 12. So y is equal to 2x minus 12. That is the equation of tangent to the line. Okay, and what is we need to find is perpendicular to the line. The equation of tangent line to the curve which is perpendicular to the line. Okay, so tangent to the curve निकालना है, but that line has to be, the tangent to the line should be perpendicular to the given line. Okay, and if the two lines are perpendicular, the slopes are the slopes are product of the slope is equal to -1. So we'll use that property. Simply we'll use that property. 5y minus 5y minus 15x is equal to 13. Okay, so we'll write down that second part. 5y minus 15 is equal to 13. 5y minus 15x 5y minus 15x is equal to 13. Okay, and what is the curve given to us? Curve is y is equal to x square minus 2x plus 7. Okay, so curve is y is equal to x square minus 2x plus 7. Okay, so we'll simply write when the two lines are perpendicular to each other. So we'll simply write down here, when two lines are perpendicular to each other, the product of slope that is m1 m2 is equal to -1. ठीक है, the product of the slope m1 m2 is equal to -1. Okay, and comparing the given equation, 5y minus 15x is equal to 13 with slope intercept form. And what is slope intercept form is y is equal to mx plus c. और यहाँ पर हमें क्या गिवन है? 5y is equal to 15x plus 13, or you can simply write y is equal to 3x plus 13 by 5. Okay, and if you compare this equation with y is equal to mx plus c, so we get m is equal to 3. ठीक है, and slope of the tangent to the curve, slope of the tangent line will be equal to m2 is equal to -1/3. ठीक है, is equal to dy by dx is equal to d by dx of x square minus 2x plus 7. Okay, so we'll simply use that. Okay, and we'll simply use that, and we'll see 2x minus 2 is equal to -1/3. So 2x is equal to -1/3 plus 2. We'll solve that equation, and that will be 2 minus 2 3 is 6, 6 minus 1 5/3. So 5/3. So x is equal to 5/6 is the point. Okay, and substitute, we'll simply write, plug the value of x into y is equal to x square minus 2x plus 7. So y will be equal to 5/6 square minus 2 into 5/6 plus 7. So how much it will be? 25/36, and this will be 5/3 plus 7. And if you solve this, how much it will be? So 36 into 7, something more than that. Okay, and let's see how it is. Let's see how much it is. So that is 217 by 36. So that is 217 by 36 here. Okay, so we get two coordinates. We get the coordinates of x and y here. So we get x naught y naught is equal to 5 by 6 and 217 by 36. M2 is equal to slope of the tangent to the curve. M2 is equal to minus 1 by 3. So we'll simply write equation of tangent to the curve. Equation of tangent to the curve. Equation of tangent to the curve, which is y minus y naught is equal to m2 x minus x naught. Okay, so y will be y minus y naught, how much it will be? 217 upon 36 minus 1 upon 3 x minus 5 by 6. Okay, and if we solve this equation further, so that will comes out to be x plus 3y. X plus 3y is equal to 227 upon 12. Okay, so x plus 3y is equal to 227 upon 12, and this is the required equation. This is the required equation of tangent to the equation of tangent to the given curve, where perpendicular to the tangent line is given to us. Okay, a line perpendicular to tangent line is given to us, and we were supposed to find the equation of tangent to the curve, so we have find it out. Okay, so let's see and how it goes. Okay, so this is how you need to solve, and you need to apply the same logic in order to get the answer. Okay, so I hope everything is quite clear to you. Okay, and I hope you have understood this part as well. So let's try to solve, and let's try to solve one more question from the same topic. And here we have, show that the tangent to the curve. Okay, so that tangent to the curve at the point where x is equal to 2 and y x is equal to minus 2 are parallel. So tangents to the curve, okay, at these 2 points are parallel. So when the tangents are parallel, when the equation of tangents are parallel, or you can say when the two lines are parallel, their slopes are equal. Okay, so we'll use that property. When the two lines are parallel, their slopes are equal. We'll simply write down as we know. When two lines are parallel, their slopes are equal. When two lines are parallel, their slopes are equal. Okay, so slope of tangent to the curve, y is equal to 7x cube plus 11 is dy by dx, and dy by dx, as we know, is d by dx of y. So that will be 7x cube plus 11, and that will be 21 x square only, because 11 will get cancelled. 11 will be the dy by dx of 11 will be 0, because that is the constant. Okay, and we will find dy by dx of at x is equal to 2. So at x is equal to 2, it will be 21 into 4, 84, and similarly dy by dx at x is equal to minus 2. (21 into 4 is equal to 84. Okay, so we have shown that the tangents to the curve at the point x is equal to 2 and minus 2 are parallel, because when the two lines are parallel, their slopes are equal. Okay, and guys, I hope you have understood. So please do like and subscribe to the channel, and please share it with your friends. Okay, So find the point on the curve at which the slope of the tangent is equal to the y coordinate of the point. Okay, the slope of the tangent, okay, let's see. So slope of the tangent is dy by dx is equal to the y coordinate of the point. Okay, okay. So y is equal to x naught. So let's see. Let's find out slope of tangent to the curve is dy by dx. So dy by dx is equal to d by dx of x cube, because here we have y by slope curve is y is equal to x cube, so that is 3x square. ठीक है, और slope of tangent to the is equal to the y coordinate of the point. ठीक है, so that is equal to dy by dx at x naught is equal to 3 x naught square. Okay, and that is equal to y naught. ठीक है, that is equal to y naught. So we'll simply use that equation and ठीक है, और y naught क्या होगा, if we let's substitute this into the given equation. So let's find out the y coordinate of the point. ठीक है, तो अगर x को x इज इक्वल टू x नॉट रखेंगे तो y नॉट विल बी इक्वल टू x नॉट क्यूब. ठीक है, सो यहाँ पर x नॉट y नॉट आ गया हमारा 3x नॉट स्क्वायर, और यहाँ पर आ गया y नॉट इज इक्वल टू x नॉट इज क्यूब. ठीक है, सो कंपेयरिंग इक्वेशन 1 and 2, comparing equation 1 and 2, what do we get here is ठीक है. So from here we get x naught is equal to 3. From here we get x naught is equal to 3, and simply y naught will be equal to 27, because y is naught is equal to x naught cube. ठीक है, so these are the point. These are the point x naught and y naught is equal to 3 and 27. ठीक है, and we are supposed to find these 2 points. We are supposed to find these 2 points. ठीक है, so we were supposed to find these 2 points, and there can be one more point, and the point can be 0 0. At 0 0 this will be equal as well. ठीक है, so x naught is equal to 3 and x naught is equal to 0 as well here. So when x naught is equal to 0, the y will be 0 only. ठीक है, so these are the 2 point for these are the 2 point when the when the slope of the tangent is equal to the y coordinate of the point for the given curve. Okay, and guys, if you have any difficulty in solving and getting how to get the answer, knowing how to get the answer, so please let me know in the comment box. Okay, and let's try to solve one more question from the same topic. So here we have find all the point at which the tangent passes through the origin. Okay, so tangent passes through the origin, it means the tangent the equation of the tangent line should have the point 0 0 as the point on it. Okay, so we'll simply use that property. Okay, so equation of tangent to the curve, or before we write down that, we'll write out slope of tangent to the curve. Slope of tangent to the curve. Slope of tangent to the curve is dy by dx, and dy by dx will be equal to d by dx of 4x cube minus 2x की power 5, which is 12x square minus 10x की power 4. ठीक है, and find the point on at which the tangent passes through the origin. Okay, so find all the point at which the tangent passes through the origin. ठीक है, so tangent should pass through the origin. So equation of tangent to the line should pass through the origin. तो हमें वो पॉइंट निकालने सारे के सारे. So let's see how it goes. ठीक है, so let us assume one of the point on the curve is, so let's see one of the point on the curve. Let's see, let one of the point on the tangent line is x naught, sorry, x and y. So and the other point is 0 0, so slope of the tangent line is y minus 0 upon x minus 0, and that should be equal to 12x की power 4 minus 10x की power 4, sorry 12x square actually, here we have 12x square. ठीक है, and y will be equal to 12x cube minus 10x की power 5. So this is the equation that we got for tangent line. Okay, and if we like substituting the value of y into the equation 1, if we substitute the value of y into the given equation, okay, and so what do we get from here is, so substituting the value of y coordinate into x into given curve, which is y is equal to 4x cube minus 2x की power 5. ठीक है, क्योंकि ये y कोऑर्डिनेट ही मिला ना एक्चुअली. सो y इज इक्वल टू, सो दिस विल बी 12x क्यूब minus 10x की power 5, and that is equal to 4x cube minus 2x की power 5. Okay, and if we try to solve this, so it will be 8x cube plus, sorry, 8x cube is equal to 8x की power 5, and from here we can see that 8 will get eliminated, and this will be x square is equal to 1. So x is equal to, this is 1 and this is x square. तो x की वैल्यू एक तो आ गई प्लस माइनस 1 और एक आ गई 0. सो दीज आर द थ्री पॉइंट. ठीक है, अब बेस्ड ऑन दैट विल सिंपली फाइंड द वैल्यू ऑफ y. ठीक है, सो y कोऑर्डिनेट y है ना, सब्स्टिट्यूट दैट इनटू द value of x into given curve. वो क्या है, y is equal to 4x cube minus 2x की power 5. So we'll simply write x at x is equal to 0. We'll simply write at x is equal to 0. So y will be at x is equal to 1 and at x is equal to minus 1. Okay, we'll simply write that. So x is equal to 0 पे क्या होगा, so y will be 0 only, and at x is equal to 1 y will be 4 minus 2 is 2, and x is equal to minus 1 y will be minus 4 plus 2 minus 2. Okay, so these are the 3 points, these are the 3 point, one is 0 0, the other is 1 and 2, the third one is minus 1 and minus 2. So these are the point where the tangents pass through the origin. ठीक है, so one of the point on the tangent line is xy, the other is 0 0. So slope of the tangent line निकाला, यहाँ से y की वैल्यू आ गई, that y is the coordinate here. ठीक है, तो उसको उठा के फर्स्ट वाली इक्वेशन में रख दिया, we get the value of x. तो 3 value of x we got minus 1 plus 1 and 0. We substitute that equation into the given equation, जो हमें given कर्व दे रखा है, we get the value of y from here. ठीक है, तो इस तरीके से हमें मिल गई y की वैल्यू और x की वैल्यू भी. ठीक है, so we get 3 points. Okay, and guys I hope you have enjoyed and solved and learned the part. ठीक है, तो चलो कल चलते हैं, एक और क्वेश्चन सॉल्व करते हैं. Here we have find the point on the curve at which the tangents are parallel to x-axis. So guys, when the tangents are parallel to x-axis, as we have discussed, dy by dx is equal to 0. Tangents are parallel to x-axis meaning dy by dx is equal to 0. ठीक है, so we'll simply write down here when tangents are parallel to x-axis, slope of the tangent line is 0. Slope of tangent line, which is dy by dx, is equal to 0. ठीक है, so dy by dx is dy by dx of y, and y is not given here. ठीक है, so we'll simply say using implicit differentiation, using implicit to get differentiation to get dy by dx. So that will be dy by dx of x square plus y square minus 2x minus 3 is equal to dy by dx of 0. So that is 2x plus 2y dy by dx minus 2 is equal to 0. Okay, and from here we get dy by dx is equal to 2 minus 2x upon 2y. Okay, and that is 1 minus x upon y. ठीक है, and if it is 0, so x is equal to 1. Okay, and at x is equal to 1, y is how much? Let's see, substituting the value of y, substituting the value of x, substituting the value of x into given equation, which is x square plus y square minus 2x minus 3 is equal to 0. ठीक है, अब इसमें x is equal to 1 रख देते हैं, तो 1 plus y square minus 2 minus 3 is equal to 0. So y will be equal to y square actually will be equal to 4 and y will be equal to plus minus 2. ठीक है, so we get 2 points. ठीक है, so at x is equal to 0, sorry, x is equal to 1, y is 2, and other point is x is equal to 1, y is equal to minus 2. So these are the 2 required points at which the tangents are parallel to x-axis. ठीक है, so this is how we can solve, at which these are the 2 points at which the tangents are parallel to x-axis, 1 and 2 and 1 and minus 2. Okay, so guys, if you have any difficulty in solving this question, please let me know, and if you have any part which is not understood, so please let me know in the comment box. Okay, so let's move and try to solve one more question from the same topic. Okay, and here we have find the equation of normal to the point. Okay, so equation of the normal at the point, equation of the normal at the point to the curve. Okay, so before we find out the equation of normal, we will find out the equation of tangent, or you can say the tangent, slope of the tangent to the curve. Okay, so slope of tangent to the curve, slope of tangent to the curve ay square is equal to x cube is dy by dx. So dy by dx is dy by dx of ay square, or you can simply write down x cube. In this as well, we will use the implicit differentiation. Using implicit differentiation, to get dy by dx. ठीक है, तो इसके लिए क्या करना है हमें, विल सिंपली dy by dx ऑफ ay square and dy by dx of x cube. So that will result into 2ay dy by dx is equal to 3x square. So dy by dx will be equal to 3 by 2 ay x square. This is the slope of the tangent to the curve. ठीक है, what we need to find here is slope of, ठीक है, so dy by dx, so this is slope equation of tangent to the curve, and at x is equal to am square, at x is equal to am square, this will result into 3 by 2 a y x square is am square, so that will be 3 by 2 ay a square m की power 4, or y can be we can find out the value of y, or y is given to am cube is given to 2, so we can substitute that as well. So that can also be written in this way, 3 by 2 a, y की वैल्यू है am क्यूब, थ्री बाई टू a, y is am cube, this is am square का whole square, so dy by dx is equal to 3 by 2, a is 4, e to the power 4, and m is 3 and 4, 7, m to the power 7. Okay, and slope of normal to the curve, slope of normal to the curve is m is equal to -1 upon m1. ठीक है, if this is m1, so that will be -2 upon 3 a to the power 4 m to the power 7. ठीक है, so that is slope of normal to the curve. Okay, and what we need to find the equation of normal to the equation of the normal at the point. Okay, and equation of the normal, we'll simply write down equation of the normal to the curve. Equation of normal to the curve is y minus y naught is equal to -1 upon m1 x minus x naught. Okay, so y minus am cube is equal to -2 upon 3 a की power 4 m की power 7 x minus am square. Okay, and if you substitute that, if you like try to solve this equation, so that will result into that will result into 2x plus 3my. That will result into 2x plus 3my minus am square 2 plus 3m square is equal to 0. ठीक है, and if you solve this, it will result into 2x plus 3my minus am square 2 plus 3m square is equal to 0. So this is the required equation of okay. So guys, there is a mistake here. Okay, so there is a silly mistake here. So the mistake is 3x square upon 2ay. Okay, that is the blender. We'll erase that and then solve again. So dy by dx is equal to 3x square upon 2ay. Okay, and dy by dx at x is equal to am square is equal to 3 by 2 am square whole square upon a और y की वैल्यू है am क्यूब. ठीक है, and from here what do we get is 3a square m की power 4 2a square m cube, and that will be equal to, so something will get cancelled out and it will be 3a square is get cancelled out and it will be like that. So the value is 3m upon 2. Okay, so this is 3m upon 2 only. Okay, and so we'll simply write slope of normal to the curve, if that is m1, slope of normal to the curve is equal to m2 is equal to minus 1 upon m1, which is minus 2 upon 3m. Okay, now we have equation of normal to the curve is y minus y naught is equal to minus 1 upon m1 x minus x naught. Okay, and that will be y minus am cube minus 2 upon 3m x minus am square. ठीक है, और that will be 3m y minus am square, sorry, cube, y minus am cube is equal to minus 2x minus, sorry, plus 2am square. ठीक है, so 3my minus 3m की power 4 plus 2x is equal to, we can simply write 2am square. ठीक है, और we can simply write 3my plus 2x is equal to 2m square plus t 3am की power 4, or we can take am square common from here, which will be result into 2 plus 3m square. ठीक है, so 3my plus 2x is equal to am square 2 plus 3m square. That is the required answer. That is the required answer. Okay, so this is how we can solve and try to get the answer. Okay, and if you have any difficulty in solving or knowing how to solve this, so please let me know in the comment box. And guys, I hope you have understood this part as well. So let's move on and try to solve one more question from the same topic. Okay, and to find the equation of normal to the curve, find the equation of normal to the curve which is parallel to the line. Okay, so the equations which are parallel to the line, equation of normal to the curve is parallel to the line this. Okay, so when the two lines are parallel to each other, so they will have their slopes equal. Okay, so slopes of the lines are equal. We'll simply use that part. When the two lines are parallel, we'll simply write it down. When the two lines are parallel, their slopes are equal. So this is the most important point you need to remember. Okay, and if you compare x plus 2y 14y plus 4 is equal to 0 with slope intercept form, which is y is equal to mx plus c. So from here we get y is equal to minus 4 minus x upon 14. So here we get m is equal to minus 1 upon 14. ठीक है, slope of normal to the curve. Which is nothing but slope of normal to the curve, and we'll say it m1. Okay, now slope of tangent to the curve, slope of tangent to the curve is equal to dy by dx. Okay, or you can simply say m2. ठीक है, so dy by dx will simply write down dy by dx is equal to d by dx of y, which is x cube plus 2x plus 6. ठीक है, so that will be 3x square plus 2. Okay, and what we need to do here is we need to find the slope of normal to the curve is m1 is equal to minus 1 upon m2. Okay, so that is minus 1 upon 3x square plus 2. Okay, and this is equation 1, this is equation 2. Comparing equation 1 and 2, so minus 1 upon 14 is equal to minus 3x square plus 2. ठीक है, and it will be equal to 3x square plus 2 will be equal to 14, and 3x square will be equal to 12 by will be equal to 12, and here from here we get x is equal to 4, and the value of x will be plus minus 2. Okay, so we get value of x is equal to plus minus 2, and we need to find the equation of normals to the curve. Okay, So equation of normal to the curve at x is equal to 2. Okay, so we will simply find the value y coordinates here. At x is equal to 2, y is equal to, which is, so curve is dx cube plus 2x plus 6. Okay, x cube is, so this will be, so y will be equal to 2 cube, 2 into 2 plus 6, so 8 plus 4 12, 12 plus 6 is 18, and at x is equal to minus 2, at x is equal to minus 2, y will be equal to minus 2 cube plus 2 into 2 plus 6, so that will be equal to minus 8 minus 4 plus 6, and minus 8 and minus 4 is 12, so that will be minus 6. ठीक है, so हमारे पास दो पॉइंट आ गए, so we get 2 points. The one is 2 and 18 and the other one is minus 2 and minus 6. Okay, and what we need to find out is equation of normals to the curve. ठीक है, so equation of normal to the curve will be equation of normal to the curve is equal to y minus y naught m1 m1 x माइनस एक्स नॉट. ठीक है, और यहाँ पर विल सिंपली राइट डाउन एट x is equal to 2 and y is equal to 18, so y minus 18 is equal to minus 1 upon 14 x minus 2, and if you solve this equation it will be y is equal to minus x by 14 plus 1 by 7 plus 18. Okay, so minus x by 14 plus 1 by 7 plus 18. Okay, and y will be equal to minus x by 14 plus 18 into 17. 18 into 7 is how much? 18 5 is 90, 108 and 126. So that is 126 upon 7. ठीक है, और it will be 252. So we can simply write down 14y plus x is equal to 252. This is the one of the equation to the normal to the curve, and we will simply write at minus 2 and minus 6, at minus 2 and minus 6, so that will be y is equal to, sorry, y minus y plus 6 is equal to minus 1 upon 14 x plus 2. ठीक है, so that is y is equal to minus 1 upon 14 x minus 1 upon 7 minus 6. Okay, and that will be y is equal to minus x upon 14 minus 42 upon 7. Okay, and that will result into y plus x plus 84 is equal to 0. So these are the two equations of normal to the curve. So these are the two equations of normal to the curve. ठीक है. So guys, you can solve it this way, and I hope it has been more around 2 hours. So we'll try to solve these remaining questions in the next class. Okay, and let's try to solve this question in the next class, and I hope you have enjoyed and learned the part. So guys, thank you very much for your time. Have a nice day. Bye bye. Take care.